Okay, guys, so we will start. So, this is the first question. As you can see, we are given two possible kernel functions, and the question is asking which of them is valid and which of them is not. Okay, so if you look at the first one, what does it say? It says x1, y1, x2, y2, and then x1 plus x2 along with y1 plus y2. So, you can easily write this as x1, x2, x1 plus x2 multiplied with y1, y2, y1 plus y2. Okay, so the first kernel option that is given, which is k1, is a valid kernel where phi is, this is phi of x1, or you can say phi of x, the in fact the transpose of this, and this is phi of y. So this is a valid kernel. But what about k2? So before even analyzing, yeah, it's not valid because here you have x1 and here you have y2, right? So it is not even symmetric. Okay, not even symmetric. So k1 is valid, k2 is not valid. Okay. Here we have another question which is along the similar lines. It has given us a function, and this is the function 1 plus x transpose y whole square, and they've asked for what is this mapping phi which corresponds to this, right? Now this is also straightforward. You just have to do 1 plus x transpose y whole square. If you expand it using x1, x2, y1, y2, no, not whole square. Square is only on x transpose y. So this will end up to be x1, y1 plus x2, y2 whole square, right? And that turns out to be 1 plus, if you expand this, you'll get x1 square, y1 square, x2 square, y2 square, and then there will be another term which is 2 times x1, x2, y1, y2, right? From here itself, you can observe that you have a 1 here, and here you have the square terms. Here you have the, so these are the square terms of the first component, then you have the square terms of the second component, and then you have a 2 and then the product of these components, right? So essentially this can be written as 1 x1 square x2 square under root 2 x1 x2 multiplied with, yeah, go ahead, y1 square. This is the second question. Okay. So we can write it in this manner where this is my phi of x transpose, this is my phi of y. Okay. So what is my phi of x1 or phi of x? It has a 1 x1 x2 x1 square x2 square and under root 2 x1 x2, which is actually the first option. The order changes here and there. In fact, the order doesn't matter. Uh, what matters is which all terms are present. Okay, so order doesn't matter. Ah. Yeah, yeah, symmetric, not just symmetric. If you're given a matrix, you have to check for symmetric as well as some other properties like positive semi-definite. Cool. The next question says given n data points in a d-dimensional. Ah, ah, ah. Yeah. Oh, So this is like saying that if you have a1 a2 plus b1 b2, you can write it as a vector, uh, a row vector a1 b1 multiplied with a column vector a2 b2, right? Yeah, this is what I have done. Check carefully. I've taken these components on one row vector and the other components on the column vector. And what I've done is that on the row vector, all of them are x, and on the column vector, all of them are y. So my objective is to break it down into dot product of two vectors, one of which is function of x, the other one should be function of y. If I'm able to do that, then it is a valid kernel. If I'm able to do that, then it's a valid kernel. If I'm unable to do that, then it's perhaps not valid. Is that cool? Okay. So now the question says, given n data points in a d-dimensional space with non-linear relationship, we apply kernel PCA to reduce the dimensionality and select the first k principal components. Is it possible for k to be greater than d? Uh, since this is a non-linear, so since we have to capture non-linear relationship and we apply kernel PCA, it is possible. If it were PCA, then it is not possible. Okay, because oftentimes this k, only restriction on k is that k should be less than capital D. Okay, what is capital D? Capital D is the dimension of the big space that you map into. Okay, and this number of components that you select, that should be less than this capital D. It can be more than D, more than small d. Okay, it doesn't matter. It can be less than small d also, doesn't matter.
This is only for non-linear relationship, right?
Yeah, this is only for non-linear relationships. If it is linear and if we are using normal PCA, then it is not possible.
Then
Yeah, right. Cool. All right, so we have another question. This is also on PCA and reconstruction error. So the question is this, that basically they are asking for various expressions of the reconstruction error. Okay, so the first, where, okay, reconstruction error of what? Of some data points xi, right? And then its reconstruction. What is its reconstruction? Its reconstruction is the projection of xi onto w, right? Where w, the norm of w is 1. And what is this? What is this entity? This entity is nothing but x transpose w times w. Okay. And this was holding because w norm is 1. If it is not of norm 1, then the formula will be something different. So
divide by W.
yeah, not, yeah, right. You have to divide by w. Okay. In fact, you can do it like this. Yeah, you can do it by norm of w and then w by norm of w.
Yeah, you need vector control.
Ah, correct. So you can write it as x transpose w by norm w cos square times w. Or you can also write, some people write this as inner product of x with w divided by inner product of w with w times w. Okay. These are all same things. Okay. Okay, so what is the reconstruction error? The reconstruction error is nothing but you take 1 by n and you take the difference between xi's and the projection of x onto w, right? Which is nothing but xi transpose w times w norm square. And this is obviously the first option. But now using the fact that norm square is same as, so if you have let's say norm of, let me not write it there. So if I have norm of v square, that is same as v transpose v, right? So using that, I can write this as xi minus xi transpose w times w transpose xi minus xi transpose w times w. Now that is the second option, right? Now one more thing. Now if I expand this, what will happen? If I expand this, then I'll get um, xi transpose xi, right? Then I will get minus xi transpose w ka whole square Okay. Uh, Again a minus xi transpose w whole square. Okay. And then a plus of xi transpose w whole square. Okay. So now this can be written as 1 by n times summation of xi transpose x minus xi transpose w whole square. Okay. So if this were a minus, so this symbol is very badly recognized. But if this were a minus, then this is also true. But yeah, it's an issue here. Okay, it's a printing error, I guess. This is not true. Okay, this is not true because you have an xi transpose xi term here. Okay, that is being ignored. Okay, that's pretty much it. Let's go to the next question. So the next question, which one? This one? Yeah, sure. So the idea is that what is k though? K is the number of principal components that you want to choose. Okay. So when you are in, okay, let's say you are initially in R2, then you are applying a 5 map. Let's say to capture square features, right? Then you will end up in 4 choose 2, which is 4 into 5 by 4 into 3 by 2, which is 6. So you'll go to R6. Okay. If you are using a polynomial kernel of degree 2, polynomial kernel of degree 2 if you are using, then you'll move to R6. In R6 you can always choose k to be equal to 3 also, right? But this k equal to 3 is bigger than 2. Okay, that is what they are saying. Is it possible that the number of principal components is bigger than the dimension of the original space? That is possible. We only want it to be less than the dimension of where we are going to. Okay, in the kernel in the transformation phi. Okay, that is the difference. Is it clear? Okay. All right. All right. So, so here we have a question on maximum likelihood estimate. Okay. So it says let these be the IID samples with parameter theta, which follows one of the following PDFs. Okay. So if theta is equal to -1, then you have this PDF. If theta is equal to 1, then you have this PDF. Okay. You have to find the maximum likelihood estimate of theta, right? Okay. I see. So what is the likelihood though? Here the likelihood is slightly tricky. So the likelihood is nothing but a function of theta given x, right? And this is nothing but the product of the PDFs, right? So it would be product of I running from 1 to n 5 xi to the power 4 if theta is equal to -1, and this would be equal to product of, not product of, it will be just 1 if theta is equal to 1. Okay. So this is the function, the likelihood function, right? It's a function of theta. So we can always condition, or you can say we can always branch on theta, right? But now we have to find for which value of theta, for this value or for this value, it is maximum, right? Now definitely if the above term, okay, if this term is bigger, then this is my MLE, and if this term is bigger, then this is my MLE. That is exactly what the question says. If yeah, this is true because one is bigger, so my MLE would be theta equal to 1. Similarly, if my product is bigger, then my theta hat MLE should be -1. Last option. Okay. This is actually a very straightforward case of maximum likelihood estimate. You don't even have to do differentiation and all. Just look at the conditions and you can say. Because there are only two values of theta, right? Typically, if your taking derivative and all, there are uncountably infinitely many values of theta, right? That is why you have to take derivative. Here there are only two values. Just compare the values and say that which is the theta for which the likelihood is maximized. Okay. Okay, so here we have a question on eigenvalues. So the question says that the eigenvalues of a covariance matrix of a center data set in R5 are these guys 3, 10, 10, 0, 0, right? Standard PCA is performed. Okay. What is the variance captured by the top two principal components expressed as a percentage of the total variance, right? This is probably everyone knows that if you want to look at the variance captured by top, let's say top k principal components, then what you do is that you add up the top k eigenvalues and divide by the sum of all eigenvalues. This is top k eigenvalues. Okay, so here it would be what? Here it would be, because you want to capture top two principal components, so it will be 30 plus 10 divided by, right, 4 by 5, which is 8%. Okay. Here we have another question. This is on k-means clustering. Okay. So here what is happening? So we are given, yeah, we are given, okay, this is I think for, this is k-means. So we are given some data points. There are 7 data points, right? And we are given the initial cluster centroids. So these are the initial cluster centroids. Remember that in k-means you can either start with randomly initializing the cluster centroids, or you can also start with randomly initializing the cluster assignments. Okay, both of them are possible. So here they have randomly initialized the cluster centroids and then they are starting the algorithm, and then they have already given us the distances of the data points from the initial cluster means. Observe quickly that there are some wrong values here. So for example, this is not 2.
Last two.
Yeah, and it should be 4, and this is also wrong, I think, right? 9, it should be 9, no?
Even if we look at the last one,
Ah,
case of 5,
ah,
it should be 25.
so there are a lot of, yeah, there are a lot of issues with this data, but let us assume for the time being that these are correct. Okay, let us assume these are correct. Assuming, because to be honest, in the exam hall we will not go to check this, right? I mean, we'll just start using these values. And what the question says is that as per these cluster centers, the data points are then assigned to either cluster 1 or cluster 2, right? How are they assigned? Looking at whichever is minimum, right? So what is Zi? So if I have another, let's say, let me remove this. If I have another column Zi, right? Then this would be what? This would be first cluster. This would be first cluster. This would be first cluster. This would be second cluster, second cluster, second cluster, second cluster. Okay, right? And it says as per these clusters, the data points are then assigned to either cluster 1 or cluster 2. Okay. Uh, Now, what is happening is that after this assignment, what will be the value of the objective function? So this was a controversial question. Some people said that you have to uh, do the reassignment and then do it. Some people said you don't have to do the reassignment. So ultimately, it was decided that both uh, class of people got marks. Okay, so if you do it, so let's anyway do it. So this objective function, if I evaluate, uh,
It is not asking for a reassignment.
yeah, it is not asking for a reassignment. So let me do it both ways, okay? Without reassignment. So in case of these questions, you can just post on Discourse and say that you have taken this approach, and then they will, most of the time they will consider it, okay? So without reassignment, what would this be? It would be minus 1 0 minus 1 0 uh, norm square plus minus 1 1 minus what I will do is that let me just write it here in the table itself, okay? That will be easier for you guys. Let me write it here itself. So this is without reassignment, without recomputation of means, okay? So this would be what? This would be 0. This will be, no. I'm computing the distance between xi and mu1 0. So this is the distance between xi and mu. So this would be 0, this would be 1, right?
In this table also they have given this one.
No, oh wait. Ah, right. These values, yeah.
Exactly.
But not all of them. You only have to take the first three. And here you have to take these. So, yeah, correct. So 1 0 1 1 and then again 0 and then 2 and then 2 and then 2, right? So it's 9, yeah. 8, right? Yeah. And if you do the then it will be different, okay? So the answer is 8, okay? If you're not reassigning. So if you're reassigning, then it will change slightly. I think it will be 6 or something from what I remember. But yeah, you guys can try it out. It's very straightforward. It's little computationally hectic, but yeah, straightforward. What you have to do is that you have to update the. So okay, I'll just mention it with recomputation. So with recomputation of means, what will happen is that you'll have to compute mu1 1 and mu2 1. Okay, what is mu1 1? It will be the average of the first three guys. Yeah. So it will be this is minus 1. This will be minus, this is 0. Okay. 1 by 3 comma 0, right? Sorry, minus 1 by 3 comma 0. And this will be
So there will be a two, no? Dot in the bottom.
y2. Uh,
Yeah, it was.
yeah.
Two.
Yeah. Uh, So we are taking the average of the first three guys. Okay.
It will be one minus one comma zero.
Oh, yeah, right. Minus 1 comma 0. There is no minus 3. Yeah, right. Correct. My bad. Minus 1 0. And in case of the second one, it will be 3 comma 0, is it? Okay. So after this, you have to compute the distance of the first three guys from this and the distance of the next four guys from this. Observe that the distance of the first three guys from this will remain the same because it is not actually updated. So it's the same, right? So you don't have to worry. So you'll get the values as 0, 1 and 1 only, same as before. But for this you have to do some updation. Uh, if you do 2 comma 0 minus 3 comma 0, it is 1 and then again 1, again 1, again 1, right? So it's 6, it's total of 6. That's how, if you are recomputing the mean, then it is 6. Okay, cool. Huh. Uh, okay, so you know about k-means clustering, right? So in k-means clustering, what do we do? There are two steps. One is that you compute the means on the basis of the cluster assignments, and then you update the cluster assignments. Then again you compute the means. Then again you update the cluster assignment. This goes on, right? So here they are asking that you're starting with these random initialization, okay, and then these are the distances. They have given the distances, and then they are asking what is the value of the objective function after the cluster assignment. So after doing the cluster assignment, you have to compute the value of the objective function. That's all. Okay.
What we have taken for which value?
See, as far as I remember, I did not do recomputation of means. I got this answer 8. Okay, and there were other people who did recomputation, and then on discourse there was a see. This is a very what do you say, it is not clear if you have to do recomputation or not, right? So some people did, some people did not do, then they raised an issue on discourse, and then ultimately it was decided that both will get marks. Okay, this was a controversial question. Okay. Hmm.
What exactly the
Oh, after ZI calculation, we have understood which data points belong to which cluster. So we saw that the first three data points belong to the first cluster, and the last four data points belong to the second cluster. And then uh, we took the distance of each data point from its cluster centroid or cluster mean, and then we added them up. That's all. Is that okay?
after adding both distances, 8 will come, right?
Huh.
Then
Then what? 8 is the answer.
where is the
Yeah, yeah. Because that's what they are asking, no? What will be the value of the objective function?
1 point cluster 2 comma 0 just 1
Which one? Come again?
comma 0 to 0 by 0 comma 0 to value 0 to cluster 2 के अंदर इसमें 0 लिखिए
अच्छा, हाँ, क्योंकि डिस्टेंस जीरो है ना, क्योंकि मिनिमम डिस्टेंस लेना है ना। देखिए, जेड का यही पूछ रहे हैं ना आप, ये वाला जीरो क्यों
हाँ
है ना?
हाँ
हाँ, तो ये जीरो इसलिए लिखा क्योंकि इसका असाइन हुआ क्लस्टर क्या है, फर्स्ट वाला है। अब फर्स्ट वाले के साथ इसका डिस्टेंस क्या है, जीरो है। सिमिलरली ये वाला डेटा पॉइंट का 2,0 का इसका असाइंड वाला क्लस्टर 2 है। अब इसका मिनिमम डिस्टेंस कौन सा है, मतलब 2 के साथ इसका डिस्टेंस कौन सा है, जीरो है। सिमिलरली इसका असाइंड भी 2 है, तो इसका डिस्टेंस 2 है, इसलिए हम लोग ने 2 लिया। गॉट इट? ओके, ग्रेट। Okay, guys. We have another question on Gaussian mixture models. What does it say? So there are 5 points: x1, x2, x3, x4, x5, and it says these are the values of lambda ki for the kth mixture after the e step. Okay. Then they're asking for the estimate of mu k, right? So how do you estimate mu k? So the estimate of mu k is given by, you take the weighted average of all the xi's, right? Where the weights are nothing but lambda ki, and the sum is always from I running from 1 to 5. Okay. And what will this turn out to be? This will be 0.3.
just
Huh,
just wanted to ask you something
huh, yeah.
in this case mention that lambda 3k is equal to 2.5
Lambda 3k is equal to 2.5. Yeah.
is it possible
Good question. Uh,
right
uh, lambda. It is typically not possible. Yeah, it's not possible.
it is not
Yeah,
possible
yeah. because it has to be a, I mean, see, how do you compute lambda k some j?
Probability, right?
Yeah, you have to do this entity, right? Lambda pi j normal distribution of blah 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 by summation of pi j. So yeah, it's not possible. Typically, it's not possible. But maybe in the first iteration, if you are poorly initializing, then it might be possible. Because if you're during initialization, if you don't uh, care a lot about these pi j's, right, then this might be possible. But that is again, I mean, it's very unlikely because most of the time during initialization, you should make sure that the pi j's sum up to one. Anyway,
That
yeah,
is the condition.
yeah, right, cool. Okay, so the weighted average would turn out to be something like 0.12 plus 5, okay, and then this would be what? 90 and then 0.9, I think, and then this would be 0.4, right? Divided by 0.3 plus zero point 0.1 plus 2.5 plus 0.6 plus 0.8. So you can compute this. Whatever this turns out to be, that is the answer. Okay. Is this fine? Okay. Hmm. Yeah. But yeah, I have multiplied. Yeah. Okay. What does this turn out to be though? If anyone is using a calculator or something. 5.82. Okay. Above 1. Oh, I see. Okay. And the final answer is? Okay. So 5.82. Okay. Yeah, okay. Okay, great. Anyway, yeah, this is the answer. Okay. Okay. Consider a dataset with 100 total points. Each data point is, so this is a, first of all, this is a question on MLE, maximum likelihood estimate. Okay. Each data point is classified as either type A or type B. Okay. We are modeling this using a Bernoulli distribution. P is the probability of a data point being type A. If the MLE is 0.4, how many data points of type P are there in the dataset? Straightforward. You just have to do binomial ka MLE. So let's say X denotes uh, the number of data points of, or let me not like this. Let me write it like this. So X is equal to, or Xi is equal to 1 if the data point is of type A, and it is 0 if it is of type B. Okay. And there are Xi many random variables where I running from 1 to 100. Okay. So what is the probability of x1 being equal to little x1, x2 being equal to little x2, and so on, x100 being equal to little x100? This is nothing but, in fact, this is the likelihood actually, right? This is nothing but p to the power summation of xi, okay, times 1 minus p to the power 100 minus summation xi. Okay, because if there are 40 of them, right, if there are 40 of them which are belonging to type A, then this term here, yeah, this term will turn out to be p to the power 40, and this term will turn out to be p to the power 60. Okay. If there are, sorry, 1 minus p whole to the power 60, correct, right? So, yeah, that is the idea. And this is nothing but the likelihood, okay? So this is the likelihood p x, okay? Now, we have to compute for which value of p this likelihood is maximized. So what do we do? Classic thing is, first you take log, let me take ln, okay? Uh, log of likelihood is same as, so it's summation xi times log of p, okay, plus 100 minus summation xi times log of 1 minus p, okay. Now what I have to do? I have to take derivative of this entity with respect to p, right? So that would be what? That would be summation xi by p uh, minus 100 minus summation xi by 1 minus p, okay. Now what I have to do? I have to set it to 0 and solve for p, right? What will it give me? Pxi. If I solve it, I will get p equal to summation xi by 100, okay. You'll get this if you're solving for the right hand side equation. So the left hand side equation. Okay. Now we are yet to confirm if this is the MLE. In order to confirm, you have to also take the second derivative. Okay. So you have to take this square. Haha, that I will not say. You have to figure it out. It's the classic rule of derivatives. Just think about it. Because it's 1 minus p, no? Yeah. Okay, so what is the derivative of d dx of minus x? Yeah. So what is the derivative of uh, a minus x ka whole square? That's it. -2 होगा ना, -1 भी आएगा ना, चेन रूल, तो वही माइनस यहाँ पे आ गया, ठीक है ना. Okay, so if you take double derivative, what will you get? You'll get minus summation xi by p square माइनस और उसके बाद 100 minus summation xi by 1 minus p का whole square, and then there will be two more minuses, so it will remain minus. Okay, 1 minus is because of the power of 1 minus p, and 1 minus is because of this minus before p, so it will remain minus. And this term, observe that these terms are always positive, so this entire term is negative, so this is negative. So at every point the double derivative is negative. So there are two things you can quickly conclude. One is that this function is convex, the log likelihood is convex. You can also conclude that this entity p equal to, or p hat equal to summation xi by 100 is MLE. These two things you can conclude. Okay, fine. So when you have the MLE, now what does the question say? Okay, first of all, it says that p hat is equal to, p hat MLE is equal to 0.4, right? In that case, summation xi should be what? It should be 40. So if P hat is 0.4, summation xi should be equal to 40, right? That means there are 40 people of type A. And okay, so they are asking how many data points of type B are there, so it should be equal to 60. Okay, straightforward, right? Sorry, your voice is, yeah. Uh, come again. Hmm. Point, no, 0.4 is what? 0.4 is the maximum likelihood estimate of P. Not of A, of P. Maximum likelihood estimate of P, that is 0.4. The fact that you already know that the maximum likelihood estimate uh, is sort of the average or the number of data points that corresponds to type A, that is a second matter. If you know it already, then you can directly apply it. Yeah, yeah. But in a lot of cases, that is not the case. Okay, there are distributions where the maximum likelihood estimate is not the sample mean. Okay, in PYQ and all. For example, in PYQ, in exponential. Okay, so there are a few cases like that. Yeah, yeah. Go ahead. There was some other question also. Yes, yes. Okay, right. P is the probability of data point being type A, and therefore, see. But my question is that how do you know that? Okay, from this, how did you conclude that there are 40 data points? That is why. Yeah. So you already know that the MLE of the Bernoulli distribution correspond to the sample mean, right? That you are using, right? So what I'm just saying is that, yeah, I mean, if you are confident about your results, then you can directly use it. If you are not, then do it in the standard way. There will be some. I mean, the reason I did this is because there will be some Pareto distribution coming up, maybe in the question, right? In that case, sometimes it is difficult to say what is the maximum likelihood estimate, especially of uh, you know, if even if you consider a normal distribution with mu and sigma square. And if you want the maximum likelihood estimate of sigma square, it is not equal to the sample variance. Okay, it's slightly different. Okay. Right, right, correct. Okay. So this is a question on basic projection and stuff, I guess. So it says given the vector x 3 4 and the line passing through the origin represented by w, answer the given question. Find the length of the projection of x onto the line defined by w, right? So this is something what we discussed. So the projection is given by x transpose w times w, right? When the norm of w is 1, and the length of the projection would then be this entity, right? So the length of the projection would be x transpose w. So, but here we are using w with norm 1. So this w is updated to be, let me call it something else. Let me call it w, uh, let's say w naught. Okay, w naught, w naught, w naught, w naught. So w naught is 1 by under root 2, 1 by under root 2. I'm just normalizing the vector. Okay. So what will be the length of the projection? It will be x transpose of w naught. which is nothing but 3 by under root 2 plus 4 by under root 2, which is 7 by under root 2. Okay, so if you solve this, you'll get some, think 1.4, right? So 1.5 in, I see. Yeah. Okay. The next question says calculate the magnitude of the reconstruction error after projecting x onto the line defined by w, right? So see, essentially what is happening is that you have an x, you have a w, and then you are projecting x onto w, so you have something here. So this is the projection of x onto w, right? And this is the error that you want to calculate, right? So how would you do it? So for that you need the projection vector also. So the projection vector is what? So this vector here, this is equal to 7 by under root 2 into
1 by 2, 7 by 2.
right, 7 by 2, 7 by 2, and then the difference would be what? The difference would be difference of x and the
4 minus.
yeah, so x minus projection of x onto w naught is का norm square, right? So this will be what? This will be equal to 3 minus 7 by under root 2, which is 1 by 2 का whole square, 4 minus ab 1 by 2 का whole square. This is minus 1 by 2 whole square, but yeah, anyway, this is equal to 1 by 4 plus 1 by 4. This is 1 by 2. Okay. But here they are asking for the norm, so you have to take 1 by under root 2. Okay.
Sir,
Yeah, go ahead.
sir, the point W
Hmm.
calculated by
I normalized it, so I so w naught is equal to w by norm of w, so that it becomes unit vector. Okay.
the projector is
Yeah, this is the projection. This is how you do a projection, right?
x
x ये है 3 4. X is 3 4, no? Is it clear? अच्छा ये अच्छा हाँ, तो इसमें रिकंस्ट्रक्शन एरर कैलकुलेट हो रहा है, तो रिकंस्ट्रक्शन एरर में आप क्या करते हो? ओरिजिनल डेटा पॉइंट और रिकंस्ट्रक्टेड डेटा पॉइंट के बीच के नॉर्म निकालते हो, राइट? नहीं, नॉर्म को रिकंस्ट्रक्ट नहीं किया। रिकंस्ट्रक्शन एरर का मतलब होता है कि आप एक डेटा पॉइंट लेते हो, उसको आप प्रोजेक्ट करते हो कोई और लाइन के ऊपर। अब प्रोजेक्ट करने के बाद और ओरिजिनल वाला, इन दोनों के ऊपर जो डिस्टेंस है, इन दोनों के ऊपर जो मतलब डिफरेंस है ना, उसको उसका स्क्वायर को रिकंस्ट्रक्शन एरर बोलते हैं। इनफैक्ट अब जब पीसीए करता है तो बहुत सारा एक्स होगा, तब आप इसका समेशन ले लेंगे, ठीक है ना? Cool.
should be root. Why are why should
Pardon?
that should be square root?
uh, uh, on what, like, yeah, yes, that's why I wrote 1 by under root 2. Yeah, that is the answer. Yeah, this is just, so this is norm square, 1 by 2 is norm square, this is the norm, this is the answer. Okay, cool. I think it's okay. One more question is left. Which part? Second part में we are calculating the reconstruction error. So we are computing the norm of the difference between x and the projected vector of x onto W naught. And then if you calculate the norm square, you will get 1 by 2. But here they are asking for the norm. So you have to take under root of that. So that's why 1 by under root 2. Come again. Hmm. हाँ 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 yeah yeah you have to take norm square of that residue. That residue is, yeah, that residue is what reconstruction error is. Huh, you have to take the norm square of that because the reconstruction error or the residue is again a vector, right? The residue is this vector. This, you can think about this as this vector, right? This small vector. Yeah, you have to take the norm square and then take under root.
The residue and the construction error are same.
Uh, Residue is for one data point. In reconstruction error, you take the sum of all the residues. Residue is actually a vector, no? See, what is the residue? The residue is this guy, x minus projection of x onto W naught. This is my residue, right? And the reconstruction error is iska norm square. In fact, if you have multiple data points, then it will be sum of all xi minus projection of W naught xi. Residue is a vector. This is a vector. There will be one vector for every data point. There will be one residue for every data point. Reconstruction is error is a scalar. The ideas are the same, but uh, you know the it's overall the data types are different, but the idea is the same. Okay. Go ahead. Um, it's error square, but I mean you can take this as the error also. Doesn't really matter much. See, you want to minimize, right? So if you minimize the reconstruction error or the square of that, it's the same. So I mean, I can call this to be my reconstruction error. I can do something else and say that that is my. So I can do something like. So this is all based on definitions. What is your perspective? I can also say that I can take the Manhattan distance between these guys. Uh, xi. I can take the Manhattan distance and I can say that this is my reconstruction error. My reconstruction error is the choice of the data scientist. What you choose to be the error. In the questions you will be given. Okay. But yeah, this is the choice of the data scientist. Yeah, go ahead.
Sir, एक बार sir वो जो second part है x
हाँ,
एक बार sir second part
मतलब
second part है ना जो x minus projection
हाँ, उसको अच्छा जी। तो ये जो है ना, ये आपका हो जाएगा 3,4 माइनस, ये क्या हो रहा है, ये हो रहा है 7/2 7/2। ठीक है ना? इसका नॉर्म स्क्वायर, इसका क्या मतलब है? इसका मतलब है 3 माइनस 7/2, 6/2 माइनस 7/2 माइनस 1/2 और ये 1/2। यही था भाई। ठीक है ना? Okay. Okay, great. Okay, we have a question on k-means. What does it say? It says k-means plus plus algorithm with k equal to 3 is applied on these points. There are 1, 2, 3, 4, 5, 6, 7 data points. The first cluster mean is chosen as 2, 1. Okay. So if you quickly plot this, what will you get? Okay, all of them are positive. So 0, 1, 1, 0, 1, 2, 2, 1, 2, 3, 2, 2, 4, 3, 2. यहाँ पे ऐसे होगा ठीक है. These are the rough distribution of data points, right? And the cluster mean mu1 0 is chosen at 2, 1. So 2, 1 is 2, 1. This guy. This is my first uh, cluster mean, right? What does the question say? And the point with the highest score is chosen as second cluster mean. Yeah, that is fine. And then it says what is mu2 0? Use squared distance to calculate the scores. Okay. So first of all, determining the point is easy. You have to check for that point which is very far away. So I guess it is this point. Right? This point is the farthest, right?
2, 4, 5.
हाँ 2, 4 है ना? That is the farthest, right? So determining the point is easy. It will be 2, 4. But again, if they're asking for some scores, if they're asking for the value of the scores, then you will have to do the entire calculation कि सबका distance निकालो, फिर उसको divide करो, वो सब करना पड़ेगा, ठीक है? The second question says which point has the lowest probability of being chosen as the third cluster mean? Okay, so my first two clusters are chosen. My first one is 2, 1, and the second one is 2, 4. Now what do you do? Now what do you do? Now let me first of all let me take this down. सब क्यों आ रहा है?
We have to consider the second one as 2, 4.
हाँ, and we'll have to consider the mean actually. So minimum actually. I'll show you. Yeah.
Minimum.
Hmm. So now what are the remaining data points? 1, 0, 0, 1, 1, 2, 2, 1 is already there, and then 3, 2, I guess. And this one is, yeah, go ahead.
So like in the previous
Oh, is it 3, 2? Uh, this is 3, 2. This guy.
we cannot do only for this, no?
It is close, right?
It's close.
Just a second. 3 minus 2 का square plus 2 minus 1 का square.
Two only, no?
या 2 का अंडर रूट 2 होगा जबकि ये 4 होगा मतलब ये 2 होगा right so it's this is more far right I mean even in visually it's more far है ना 3, 2 which question
This very
हाँ so this question they're asking oh first part they're asking what is mu2 0 what is the second cluster centroid that you will choose and you will choose that one which is far away from the first cluster centroid Okay. No. You can calculate the distance and then do also. You can calculate distance of every point from 2, 1, and then you can see which of them is maximum. There also you can do. Visually it is easier, that's all. Okay. Okay, so I think these are the data points 2, 3, 3, 2, 1. Pardon? I didn't get your point. Come again? Ah, yeah. Yeah, yeah. Yeah. Ha. Cool. Okay. Okay, so now they're asking, now you have to find out which point has the lowest probability of being chosen as the third cluster mean. So what do you do for 1, 0? You have to compute the distance with 2, 1. You also have to compute the distance with 2, 4. What will those distances be? With 2, 1 it will, what, 1 and 17, right? Yeah. And no, wait. Is it, it will be 2, right? Yeah. And the second one will be 4, 4 square and 1 square, which is 17. Yeah. It, ठीक है. This will be, and this will be 1 square plus 1 square. 0, 2 comma 9, 2 comma, so 2 comma 5 is it? Okay, 2, yeah, right. And for this, okay. Now what you have to do, you have to take the minimum. So for here you take 2, for here, go ahead.
सर ये वाला जो कैलकुलेशन हुआ 4,13 और ये वाला
हाँ, ये हम लोगों ने डिस्टेंस कैलकुलेट किया, स्क्वायर डिस्टेंस कैलकुलेट किया. हाँ. Okay, just a second. It's 2,5 only, no? You're talking about this data point? Yeah, it's 2,5 only, right? Yeah. Okay, no worries. Okay, so then what you have to do, you have to take minimum. Okay, whatever is minimum you have to take, and now you have to take the largest. ठीक है ना? Largest ही लेना है ना? हाँ, largest ही लेना है. Okay, and the largest turns out to be Oh, lowest. Oh, they're asking for the lowest probability. I was thinking about the highest one. Yeah. So the lowest probability is that of this, which is 2, 3. Okay. Is this cool? Like, I mean, I didn't do a lot of calculations, but yeah, someone asked me about how these 2 and 7 are coming. So let me also explain that. For example, if you have 1, 0, okay, you are computing its distance between 2, 1. You're also computing its distance between 2, 4. इन दोनों का बीच का डिस्टेंस क्या होगा? 1 minus 2 का होल स्क्वायर प्लस 1 minus 0 का होल स्क्वायर, राइट? स्क्वायर डिस्टेंस 2 होगा, राइट? और इन दोनों का डिस्टेंस क्या होगा? स्क्वायर डिस्टेंस विल बी इक्वल टू 1 minus 2 का होल स्क्वायर प्लस 0 minus 4 का होल स्क्वायर, 17 होगा, राइट? नाउ this is how we computed 2 and 17 for the first data point. This we did for all the data points. ठीक है ना? Someone asked me about. Okay. Oh, Euclidean distance is the under root of under root of distance squared. So okay, let me write it down. Euclidean distance means it is also called as L2 norm. Okay. It is nothing but you take x minus y norm square. Sum हटा देता हूँ. X minus y norm square, which can also be written as summation of xi minus yi का whole square, I running from 1 to some d. These are the same things, okay? And similarly, you have Manhattan distance. It's also known as L1 now. Represented as oh, sorry, my bad. I made a small square root. Square root is missing. Yeah. So it is this guy, and it will be the square root of this. Okay. The L1 norm is x minus y. Some people write it as norm 1. This is written as norm 2. And then this turns out to be summation I running from 1 to d mod of xi minus y. This is the Manhattan distance. As of now, these are sufficient. Okay. Okay. I think the paper is over. Do you guys have any specific questions or something like that?
We will not be asked about the Manhattan distance.
I hope not. Yeah.
Sir, can you send the link for the
Pardon? Just question papers. Actually, I am taking it from this website. There is this website called quizpractice.space. So I took screenshots from this website and I pasted it there. That is what I did. Okay. Yeah.